Okay, so our next video is going to be about how to calculate percent composition. So in this case, we're going to be talking about a chemical or a compound, excuse me, of sodium carbonate, which is Na2CO3, which is an ionic compound. And basically what we want to do here is figure out what percent is it of sodium, of carbon, and of oxygen. So to do this, we need to separate them out. We need to write down every element we have. So sodium is one, carbon is another, and oxygen is our third one here. Okay. So here we would then figure out how many we have of each one. So for Na, we would write down that we have 2 of them. Okay. Oxygen, we write down, or carbon, excuse me, we have only 1, because that 3 only applies here. If this was in parentheses, then it would apply to the carbon and the oxygen, but it only applies to oxygen here. So here we have 3. At that point, we would then multiply them by their atomic masses. So we need the periodic table for these. So if you look at the periodic table, we'll start with sodium. Okay, sodium is right there. Okay. So the amount for sodium is 22.99. 22.99. Carbon, which is one we've been using quite a bit, and we should remember, and oxygen, I'll go ahead and show you at the same time. So our carbon is 12.01, and our oxygen rounds to 16.00. So for that, we would write down 12.01, and then 16.00. So at this point, we then need to figure out the total molar mass of this. We need to figure out how much do all of these things add up together. So we start with sodium, and that should be 22.99 times 2. So if we type that into our calculator, I got the number of 45.98. Okay. And then 1 times 12.01 remains the same, 12.01. And then 16 times 3 gives me a total of 48.00. 48.00. And then we add those up. We need the molar mass to add up, so we're going to add 48 plus 12.01 plus 45.98. And I got a total of, let's see, that should be a 9 here. 9 there. And we got 8, 10, 15, that's a 5. Carry over the 1. And that should be 4, 8, 9, 10. So it should be 105.99. Okay. Now, we need to know the percent composition. So this right here is grams per mole, right? Or otherwise known as molar mass. Okay, so if we were going to do a conversion of this, this would come in handy. But right now, we're not doing a conversion. We're trying to find out what percent is it of all these things. So to do that, we need to take each one and divide it by the totals. Okay, so here, 45.98 should be 105 divided by 105.99. Same thing here, divided by 105.99 divided by 105.99. And these numbers that we get for all of these are going to be small decimals, and that's fine. It's not a big deal. So we would take 45.98 divided by 105.99, and I got 0.43 after we round. And then over here, 12.01 divided by 105.99, and that gives me 0.11. And then finally, 48 divided by 105.99, and that gives me 0.45. Okay? And so if you add that up, that should come out to almost 1. So that's 5, 6, 7, 8, 9, and then 4, 5 plus 4 is 9. So that's 0.99. That's pretty close. So with rounding, it basically equals to 1, and that's fine. Now at this point, we need to take each one and multiply them by 100. That will give me percentages, because that is what we want, percent composition. So I'm going to put these answers over here to the left so you can see what our final answers are. Basically, if you're remembering a little bit of your math, you just move the decimal twice. So this is going to be 43% sodium, because that moves over twice. This one's going to be 11% carbon, and that one's going to be 45% oxygen. And those are our percents of each element. And that's how you do percent composition. So it's really not that hard, it's just a couple extra steps.